Hello everyone, welcome back. This is Nikhil. Today we'll be discussing about the seismic analysis design of the tall building. Okay, yesterday we have considered the tall building. Right now here it is. Open the yesterday's previous one file here. We have performed the analysis and design for dead, live and wind loads. Okay. Today we'll be performing the seismic analysis. First of all, we need to unlock the model. Okay. Now we can perform the modifications or changes to this tall building. Okay. Now go to define. First of all, go to define load patterns. Add seismic load here. Okay, seismic, and select type as seismic, and corresponding code is IS 1893 2002, and click on add new load. Okay, and we'll select this seismic and we'll modify this lateral load. Okay, and here we consider the seismic load acting only in x direction and only y direction. Okay, we are not considering the eccentricity. And the seismic zone factor for the Bangalore city we have already discussed yesterday. Based on the code. Okay, Z is 0.1 and sill type site type is zone 2 and importance factor is 1. Okay, the time period here it is program calculated. The program itself calculates the time period according to the building dimensions. Okay, and the response reduction factor from the table 7 of IS 1893 we have got is 3 value. Click on OK and click on OK. Now we have defined the seismic load. Now go to define load combinations. Okay, yes, already the predefined load combinations are here. Okay, now click on OK. Assigning of seismic load is now completed. Okay, now we need not select any building element to assign the seismic load. By default ETAPS will assign the seismic loads. Okay, we need not worry about the selecting the part of the building to assign where. Okay, there is no tension for us about that. Now analysis, go to analyze, select set load cases to run. Okay, we'll performing only dead load, live load and seismic load here. Okay, all of you are running. Okay, and click on run now. Wait, meanwhile, wait. The ETAPS will run the analysis. It may take time. We can see the process of the analysis in the right bottom left corner here. Okay, right. When the analysis is completed, the 3D will change to 3D view displacements. Okay, by this we can say that analysis is completed and we can see the maximum displacements. Okay, now we will be designing. Okay, go to design, concrete frame design, view revise preferences. IS 456 we are designing. Okay, click on OK. Go to design again, concrete frame design, and start design slash check. As we are performing the seismic analysis, there is no need to perform the wind loads also here also. So we have deleted the wind loads combination, all those things. We are performing only the dead, live and seismic loads itself. Right, it's showing 7 frames. Okay, we'll reiterate to the next beam dimension or column dimension. Okay, with the help of auto select list. Now here we can see the design is completed right now. Now go to design. We'll check once. Okay, concrete frame design and verify all members passed. The dialog box is showing all concrete frames passed the design check. Click on OK. Now the building has been designed for seismic loading case. Now next we'll be dealing with the In the seismic loads, we have got two methods, that is response spectrum method as well as the time history analysis. First, we'll be discussing about the response spectrum method here, right? Okay. To do that, first unlock the model. Okay, right. We are unlock the model, and before perform the seismic analysis, we need to check whether the seismic load has been defined or not. For that, go to define, go to load patterns, check whether the seismic is added or not. Yes, it's added. Okay. Check modify lateral load, positive x and positive y, only x and y, and zone factors are always as previous the same. Okay, click on OK and click on OK. Now go to define, go to functions. I said there are two methods, that is response spectrum method and time history analysis. First we'll be doing with response spectrum method. Select response spectrum method. Okay, and choose function. We'll dealing with IS 1893 2002. 2016 is also available, but we'll go with IS 1993 2002 and click on add new function. Okay, enter the name as response spectrum. Okay, and the seismic zone factor we have already entered is 0.1 and soil type is type 2. Okay, and the plot options are linear x and linear y. Okay, function damping ratio 0.05. Don't need to change any of those things. Okay, and click on OK. Now response function is defined. Okay, click on OK. Now we'll set load case including the response spectrum. Okay, for that we need to check the acceleration units. Okay, first go to options, display units. In that, go to the time related, check the acceleration units here. This one, it is mm per second square, so the acceleration units are okay. We need right. Now next, go to define, go to load cases and select add new case, enter it as response spectrum. Okay, select the load case type as response spectrum. Right now, in the loads apply, we'll apply loads in x direction and y direction. For that, first we'll apply in the x direction. Okay, load type is acceleration and load name is u1 and function is response spectrum. Okay, and the scale factor we'll calculating from the IS 1893. The scale factor formula is I into G divided by 2R. Here, upon the calculation of the Bangalore city, the scale factor obtained here is 1663.5 for the Bangalore city. Okay, now we have added the scale factor here, and this is for x direction only. We have already discussed the seismic response spectrum will acting in x and y direction. For that, we need adding the second load. Okay, select the response spectrum again here, and the scale factor is same for the both x and y direction. Okay, and model case is model CQC SRS, and no need to change other things. Okay, click on OK and click on OK. We need not select any part of the building to assign the response spectrum. Okay, next step is to analysis. Go to analyze, analyze, set load cases to run. Okay, we are performing only the seismic load as well as the response spectrum. Okay, so there is no need to run the dead load and live load. Okay, select the dead load as do not run and select the live load as do not run. Okay, and click on run now. Meanwhile, wait, the analysis will be done. Right, the analysis is now completed. You can check here. Now next step is to design. Go to design, concrete plane design, view / revise preferences. See there is IS 456 and click on OK. Go to design, concrete plane design again, start design / check. Right, the design has been completed. Okay, Go to again design, go to verify all memos passed. It's showing all concrete frames passed the design check. The design is completed for response vector method right now. Next, we'll performing the time history analysis. Okay. In the next, to perform the time history analysis, now we need to unlock the model first. Unlock the model here right now. Right. Now we need to do the time history analysis. Okay. Right. We unlock the model. Now go to define. Go to load patterns. Yes, seismic load has been acted. We'll modify this lateral load and we'll in the time history analysis we'll apply the loading will all be in the x direction. Okay, we'll apply only in the x direction, and the zone factor is 0.1 and site type is 2, importance factor is 1 as usual, program calculated, and response direction factor is 3. Click on OK and click on OK. Now go to define, go to functions, select time history and choose function to add. Okay, we'll import this from the file. Okay, we'll import this from the file. Okay, now click on add new function and enter the function name as time history analysis. Time history is enough. Okay, we will browse the file name. Okay, file from the where the file location is. Okay, I'm saved in the desktop. Here it is, example time history data, and click on open. Okay, now time history data is been now browsed into this, and format type is fixed format. Okay, and the characters per item is not showing here. Why I am selecting the fixed format is to get the actual profile of this graph. I am selecting the fixed format. Okay, and the characters per item is 10. Okay, it is by default 10. Okay, and now click on view file. What the file we have imported as time history is showing here. Okay, this is the way. Okay, and before the data here, count the number of lines. How many are there? Before this is the starting part of the data. Okay, how many lines are there? 1 2 3 4 5 6 7 8 9. There are 9 lines. Okay, we need to skip those 9 lines so that the data will be read from the starting of this. The data will be reading from this. Okay, so we need to skip these 9 lines. I need to enter yes header lines to skip as 9. Okay, and the number of points per line as 1. Okay, now it's fixed format. Okay, right done. Now click on OK. Now click on OK. Now go to define, load cases, and select add new case here. Enter it as time history. Okay, select load case type as time history. Okay, and we need to add the loads here. Okay, and the load type we'll add the loads here, and load pattern is acceleration type. Okay, we'll perform the linear model itself. Okay, and the function as example time history data. Okay, and enter the scale factor we already calculated 1663.5. Okay, right, as we are applying only the x direction, there is only one is sufficient. Okay, right, the model damping ratio is 0.05. Okay, uh, in the response spectrum we had 2 because I have selected x and y direction, but here we are selecting only x direction. Okay, we need only one load is enough, and click on OK. Now time history is now defined. Okay, and we need not select any of part of the building to assign the time history data. Okay, the next part is analyze. Go to analysis, set load cases to run. Okay, there is no need to perform the dead loads and live loads. Okay, it's not there. We perform the time history only for the seismic as well as the time history analysis. So response spectrum also no need to run. Okay, only seismic as well as time history. Click on run now. Right, the analysis is now completed. Okay, now we will be designing. Okay, go to design, concrete train design, view refresh preferences. It's IS 456. Okay, go to design, concrete train design, start design slash check. Wait, the ETAPs will design for concrete frames. I'm skipping this video because it's taking time. Okay. Well, the design has been completed right here. It's showing here. Now go to design again. Go to concrete frame design. Verify all members passed. Yes, all the concrete frames passed the design check. Yes, the design has been completed for the time history analysis also. You can go for this project information. You can create the project reports. Okay, show summary report here. You can get the entire summary report of this project. Okay. Yes, the entire summary report is available here. All the load case, all the reinforcement details, all the load combinations, load patterns, load case, all will be shown here. Okay, the reinforcement all will be showing here. Storage drifts, all those things. This is about the ETAPS design of the tall building subjected to seismic loads, response vector method, as well as the time history analysis. Thank you everyone for watching.